Right, let's use the line of action to analyze systems. When you have things that are connected together, the easiest way to deal with them is to think of them as one whole system, as opposed to separate things. As we discussed in the previous exercise, when you do that, you get to ignore the internal forces. Looking at all these as one means that there's only this one force of the pull, and there's gravitational force, which is going to be on all three. And there's a normal force on all three. The line of action is this way. Right, so we're going to say this is the positive direction. So when you write out your Newton's second law for this line of action, the only force on the line of action is Fp, right? These are perpendicular, so you don't have to worry about it. So then you just have to do the force. Now the mass, remember, is the total mass, so you'd have to add them all together. So to find acceleration, it's just 50 divided by that total mass. And we're just going to leave it like that. We don't have any numbers for those, so that's fine. So that's going to be your acceleration. The bigger the masses are, the slower the acceleration, etc. Because these are all connected, they all have the same acceleration, so you don't need to find them separately. So let's look at these, right? So now if our line of action, which we should draw first, if M3 is greater than M2, which is greater than M1, right, then your line of action, this is definitely going to move this way. That's my line of action. So I'm going to sketch that in there. My free body diagram for the whole thing, all of this, right? I'm going to draw one free body diagram. So what's pulling down is FG, here is FG1, and what's pulling down here is FG2 plus 3. All those tensions are internal. So when you write your net force equation for your line of action, right, these two here are in the positive line of action. So you'd have FG 2 plus 3, and on the minus, right, this is opposing FG of 1. The total system mass is all of them, M1 plus M2 plus M3 times the acceleration. Sorry about that. So you'd have, you can break this down, this would be M2G plus M3G minus M1G. And if we divide both sides by the mass, you get M1 plus M2 plus M3 equals acceleration. So that's your expression for acceleration for this problem. Let's look at the next one. We're going to make the system everything but the surface and the earth. So my line of action, if M2 is greater than M1, then for certainly being accelerated down this way. This is my line of action in the positive direction. This way will be negative. So when I draw my free body diagram of these two things, right, I've got M, right, this is my weight, so this is M1G. This here is M2G. There's also for external forces of the normal force of the thing, and we're saying there's no friction, we don't have to worry about that. And so these tensions are internal, we don't have to worry about them. Again though, if you look at your line of action, right, normal force is perpendicular, so it doesn't matter, but M1G is actually off the axis, so we need to split this into components. So I'm going to do M1G, and that's going to be sine of 60, and this is going to be M1G cosine 60. Now this one is perpendicular to the line of action, so I don't have to worry about it. I only have to worry about what's along the line of action. So when I write this out, this is positive direction, so M2G. This is the negative direction, minus M1G sine theta, and we've got to do the total mass, m1 plus m2, times acceleration. And if you want to simplify it, you certainly could. You could pull out g. Right, so there's your expression for acceleration. In number 4, this guy is here pushing with 50 newtons. M1 and M2 move together because there's friction between M1 and M2. There's no friction between M1 and the floor. So my system is going to be the 2 boxes without the floor, without the person. So these move together. I'm going to assume here's my line of action. I'll make that way positive. So here's my 2 and 1. So my external forces, so I've got the force of the push, I've got normal force of the floor on 1, and I've got the force of gravity of 1 and 2 together. There's no friction between the floor. The friction forces between the 2 boxes are internal to the system. The normal forces between the 2 blocks are internal, so this is it. So when I write my line of action second law equation, all I've got is this push, and I made that way positive. And you just have to remember to add the total system mass in. So it's going to be 50 divided by m1 plus m2 equals acceleration. Very much the same as number 1, different situation. Come up with almost the same equation. 5. So here's the system, all 3 objects, not including the table. There's no friction between M2 and the table. They tell you that M1 is greater than M2, which is greater than M3. So the line of action looks like it will probably be like this. I'm going to make that way positive. So my free body diagram, 1, 2, 3. So I've got this weight, so you can call it Fg or you can call it M1g. This is M3g. There's a normal force here, and you've got M2g. There's no friction, and the tensions are internal. But if this is your line of action, like that, and this way is your positive line of action, then these forces are perpendicular. You can ignore them. So for now, anyway, so you've got M1g is positive, M3g is negative. Your total system mass, though, all 3 boxes. So make sure you include all 3 of those when you're writing out your equation. So you've got M1 minus M3 times g over M1 plus M2 plus M3, that's your mass, equals, here's your acceleration. So that's your equation. All right, last one. Here's your system. Pushing, so here's my line of action up the incline. So when I draw my free body diagram, I've got M2g, M1g, we've got the normal forces which are perpendicular to the line of action, and I've got this push. And we're not going to worry about friction. So these forces here have to be split into their components. So you've got M1g sine 30, and this one's going to give you M2g sine 30. Could group them, by the way. This is M2g cosine 30. This is M2g cosine 30. So this is my line of action. So I've got net force equals mass times acceleration. So I've got force of the push minus M1g sine 30 minus M2g sine 30 equals M1 plus M2 times A. So it's 50 minus, you could take out if you wanted to factor it. You don't have to. And there you go.